Adding fiber into material has a long history. Okay? Even if you look at history, many years ago, I'm talking about thousands of years ago, when people are using clay to make bricks to build, they already put straw inside. Okay? So this is one way of reinforcing the material. Traditional concrete is what we call a brittle material. So under tension or bending, it deforms a little bit and then it's going to break into two pieces. The bendable concrete can absorb a lot of energy because of the deformation capability, and also the ability to control cracks would make it more difficult for water and salt to penetrate into the structure, and as a result, the durability of the structure can also be improved. Traditionally, in bridges, to account for the expansion and contraction of bridges, they have to put steel expansion joints between parts of the bridge. And these joints are very expensive, and also they have to be maintained very frequently. Use this material to replace the expansion joint has already been used in Michigan, in the US. They have used it for almost 10 years now, and the results has been very good. Another application is that in seismic regions, where there is earthquakes, you can use this material in some parts of the structure to facilitate the absorption of energy so that the earthquake resistance can be improved. The use of these materials to absorb energy in buildings, those have been implemented in Japan. Actually, I know that there's a building in Yokohama where they make use of this approach to absorb energy. In Hong Kong, there are a lot of old buildings. We have problems with concrete spalling, which means that pieces of concrete are getting loose on the surface of a building and they would fall to the street. We applied this new bendable material as a mortar on the surface of the building. So when you have a piece of concrete that gets loose, when it wants to come out, this bendable layer is going to trap the piece inside. So instead of falling out to the street, you can see that on the building surface there may be some parts that bulge out, so you can go over there and to fix that part. So right now what we are trying to do is that we're trying to look at different kinds of fibers. We're actually doing some work on recycled fibers, which are much less expensive than the fiber that we are currently using in this material. So hopefully we can cut down the cost of the material significantly so that it can be more widely applied in practice.